I am totally agree with you. The movement, it's called motion. But can you tell me about the basic definition of motion? What is the basic definition of motion is here?
No.
Okay.
Mm.
If I am, the picture shows the three balls are moving. Three balls are moving.
Yeah,
What you noted?
they're moving, motion.
Motions. Okay. If I define the motion like that, when a body change its position with respect to surrounding, when a body change its position with respect to surrounding. Now, the balls are moving or not?
No.
It's mean it doesn't change the position with respect to surrounding. Surrounding mean with respect to us, from my side or your side, the ball is not change its position.
Yeah.
Okay. If I define the motion when a body change its position with respect to surrounding, it's called the body is in motion. But if the body doesn't change its, it's called body at rest. For example, at the same time, a single body is in motion or in rest. For example, you are sitting in a car and the car is moving, and surrounding the car, some your friends are standing outside of the car, and one or two friends are sitting in the car with you. You are, according to the inside of the car, you are at rest because you doesn't change your position with respect.
Yeah.
It means you are at rest. But if we are discussing the outside of the car, then outside, according to the outside of the car, because car is moving, then you are also in motion because you surrounding.
Yeah.
It means at the same time you are in rest and motion. The phenomena is when a body change its position with respect to surrounding, it's called the body is in motion. If the body doesn't change its respect to surrounding, then it is in rest. Got it?
Oh, yeah.
Okay. Now, define as the linear motion is defined as, or the kinematic is defined as, kinematic is defined as the study of motion of an object without considering the effect that produces the motion. The effect that produces the motion means the effect of the motion which is produced. But it is a very general definition. We are discussing this later in the next step. There are two type of motion. I already explained. There are two type of motion. One is one dimension motion, which is on the same axis. Same axis mean on the x-axis or y-axis or on axis, but on the single axis. When a body at a single x, it's single dimension, 1D, and it's called linear. But when a body is two dimensions, mean at the x component and y component, mean at the same time the body is moved from x to y axis or from y axis to x axis. It's called the two-dimension motion and also called the projectile motion. That's why there are two type of motions. Number one, linear or straight line motion, which also called one dimension. One dimension motion is with the constant velocity. We also describe it, inshallah, and with uniform acceleration also, which is free fall motion.
Okay.
Motion is projectile motion, which also called two-dimension motion, which we discuss in A levels, not here, but A level the projectile motion. In O level, we are only discussing the linear motion here. Okay. In the projectile motion, the motion is on a horizontal, x-axis, x component, and vertical on y component. By these all the things, the kinematics. Kinematics is a science of describing the motion of object using words, diagrams, graph, and equations. When we are describing the motion with reference, with help of words, with help of diagrams, with help of graphs, or with help of equations. That type of private, that branch of science is called kinematics. The kinematics we are using for the motion, not the force involved here.
Okay.
What is our chapter? Number one, in the end of the chapter, you will be able to define and describe distinction between the distance and displacement. It is our CIE pattern. Speed and velocity, instantaneous velocity, average velocity, and uniform velocity, instantaneous acceleration, average acceleration, and uniform acceleration. Sketch graph, how you sketch the graph of displacement time and velocity time, and also the acceleration time. The third one graph is determine the distance traveled, displacement, velocity, and acceleration from the create graphs, select bar table, by coordinates. Now, when you define the distance, what is a distance?
Mm, it's like the length, like it's a scalar quantity, but I can say it only has a magnitude. It has no direction.
Pretty done. Have direction, so that's we mentioned. Length of actual path between 2 points. Okay. Little bit I want to explain here. Sometime the teachers says that, for example, from A to B, we have 10 meters. Agar, if I'm
Okay.
A to B, then it is.
I can't hear you. Hello.
Hello, now hear you.
Sometimes your voice is not audible. I cannot hear your voice sometimes. Sometimes it's audible, sometimes not audible.
Okay, I change the headphone tomorrow, not now, because maybe you will be a little bit when you not hear me, then tell me, okay?
Okay.
Okay, if someone says that we have 10-meter distance, but if a boy someone tell us from A to B, we have meter, so it's not the is not a distance here, because when we want to know about the distance, so first of all we describing this distance is a and we are not in direction in any direction in a it's
I can't hear you again.
now it's you hear me.
Yeah, I can hear you now.
Uh, distance is a scalar quantity. So when we define the distance, so distance means the actual path between 2 points, because distance is a scalar quantity. Now, if the distance is a scalar quantity, so we are not mentioning here the directions. If I am saying that from A to B, the distance is 10 meter, it's a wrong statement. From A to B, when I involve A to B, it's mean A to B is a direction, so the distance have no direction. If the distance have no direction, then why I says that A from A to B, the distance will be 10 meter. If I am describing the distance now, it's mean I am not involving the direction here. I am only says the magnitude and unit here. I says the length or the distance is equals to 10 meter. I am not saying that distance from A to B is 10 meter. Got it?
Yeah.
Okay. Now, the second part is displacement. This, but before the displacement, I want to show the distance. For example, from A toward B, a body is moving from A toward B, like that. It's called a distance, but it's not in a straight line. But we are saying that this is a linear motion. Why? Because this body act on a single axis. The body acts only on x-axis or on y-axis. There is no horizontal or vertical component of this motion. If we have the vertical and horizontal component of this motion, that time this body is moved up and down, but in the opposite directions. So that's time it the horizontal and vertical components. And when we make the horizontal and vertical component of the motion, that time that motion is called projectile motion, not the linear motion.
Okay.
It's mean in the linear motion, it's not important that we are moving in a straight line only, but the body should be moved in a single axis. In a single axis, there is no horizontal and vertical components. The length of the path from A to B is 25 meter. It's mean is a distance of that. What is called displacement?
Displacement is the same thing as a distance, but with also a direction.
Yeah. When we provide a specific direction to distance, it's called displacement.
Okay.
I am saying that the distance in a particular direction, it's called displacement. Distance in a particular direction, it's called displacement. So displacement is a vector quantity, and it is defined as the distance between initial point and the final point in a straight line. I mentioned here the initial point and the final point mean from A to B. When we are saying that the distance from A to B, then the examiner means they want to know, they want to explain the displacement, not the distance. When we involve a direction in a distance, that time distance converts to displacement. Sometimes teacher says that displacement is a shortest distance between 2 points. Sometimes the teacher says the distance displacement is the shortest distance between 2 points. For example, from A to B. If I have a one way like this, the second way is like this, and the final one in a straight line is this. Mean it is a path A. If we have path A, path B, and path C, that time, so some teacher says that the C path is a displacement. Okay, I'm totally agree with this. But if I have the same situation, but have only one way. For example, from A, I have only this path, the C path I have, and there is no other path to come from A to B. So what is distance here and what is displacement here? A to B. For example, 10 meter is a distance here. Then what about displacement? Displacement is also 10 meter or not?
Yeah, it will be.
Because in this condition, we have a single way here. We have a single path here between the A and B, and it's a straight path. If I am describing that the C path is 10 meter, it's mean it is a distance. But when I am describing the C path, A to B is 10 meter, it's called it's displacement. It's mean displacement is always equal or less than from the distance. And distance is always equal and greater than from the displacement. I repeat the statement. Displacement is always equal or less than from the distance. Distance is always equal or greater than the displacement. Got it?
Okay. But how is it like always greater? Distance is always greater and displacement is always lower.
Yeah. Distance in the first part, example number 1 here. If I am describing here from A to B toward B, what is the C path is displacement here only. And about the path and the B path is the distance between A and B. For example, you want to travel from your home to toward the school. There are two roads which you reach your school. First road is 4
I
kilometers.
can't hear you again. I can't.
For example, you want to go to school. Okay, you have two way to reach your school. One way is 2 kilometer, and the other way is 4 kilometer. Both the way are the distance, but the short one is a displacement as well as the distance, and the longer way is only the distance. That's why I'm saying large distance is always greater than or equal to.
Okay.
Got it? What
Yeah, got it.
can I explain again?
No.
Okay. Okay, now move to the next, inshallah. The SI unit of displacement is meter, and also the SI unit of distance is also meter, beta. Remember it? Both have the SI unit meter because both are length, na? So length have the meter.
Yeah.
Okay. For example, we have an example. An object P moved 30 meter to the east after meter to south and finally moves 40 meter to west. Determine the displacement of P. We have covering start from.
Again, the voice is not audible.
Okay. From it starts trying the same method. For example, 30 meter toward east.
East.
Start from point O toward east direction. 30 meter, it's covered from O toward east. Then 15 meter toward south. Again, the body start from this point from from toward south. Toward south. Just wait. 15 kilometer toward south. Now, okay, 50 meter toward south, and then finally the body move 40 meter toward west this direction. Then total 40 kilometer from P is 40 kilometer. He covering 40 kilometer toward P. Got it?
Yes, got it.
Saying that find the displacement of the relative to the original position. Displacement is a straight line from O toward P, mean the blue one. From O toward P directly, a straight line. Calculate that distance displacement. About the distance displacement. So I clear all these drawings and then the bodies start moving. Look at the body from O toward P. How much the total distance the body covered?
The total distance?
Total distance.
We will add all the distance 30 plus 15 plus 30 plus 10.
Add it.
85.
55. Okay. Now they want to know about the displacement. How much displacement they covered. How much the displacement they covered. If they
Covered.
from O to P, they have give the direction from O to P. Okay.
P.
Okay. We have O from O to P. At O to P. From O to P. And we have a base here. 10 meter. What about this height?
15 minutes.
15, because this is like a rectangle here. Then rectangle properties are the opposite sides are equal. So this side is also equal to 15. So we mention here it's 15. Then they want to know about we make a triangle here. Triangle. They want to know about this length. It means it is adjacent, it is opposite, and this one is hypotenuse. Then they want how much the hypotenuse is. How much the hypotenuse is.
We will use a square plus b square equals c square. That formula.
Yeah, the Pythagoras theorem. It's called Pythagoras theorem, in which we are describing a square is equals to b square plus c square. But here we write h square is equals to a square plus o square. Mean adjacent square plus opposite square is equals to hypotenuse. Got it?
Okay. Yeah.
Okay. Now, come to the solution. The magnitude of the displacement is given by OP is equals to adjacent 15, opposite 15 square plus adjacent 10 square whole under root equals to 18 meter. 10 times 100 plus 150, 15 multiplied by 15 mean make the square of the 15. Then add with the 10 square. After that, get the square root. We have 18 meter. So the displacement of this from got it?
Hello?
Hello, got it? Got the point?
Yeah, got the point.
Okay. Now, because we have the displacement, then this displacement have a direction. So we want to know about the also the direction here. So that time, this theta will be calculated. The P angle. The P angle should be calculated here because they want to know about the displacement. And we know that the displacement is a vector quantity. And in vector quantity, we must include a direction because vector quantity are those quantities which completely specified with magnitude, unit, as well as the direction. Without the direction, we are not specifying the quantity. So that's why after the magnitude of the OP, we should calculate the direction as well. So we have three sides. For example, we have all the three sides of a triangle. Mean we calculated now all the sides.
Yeah.
For example, this is a triangle here. Like that. This is O. This is P. OP is 18. This point for example, I make A. So the AP is 10 and this one is 15. Now we should calculate this theta. Then how I calculate the theta? Did you remember your trigonometric ratios? The sine theta, cos theta,
Yeah,
and tan.
tangent.
What is sine theta? What is equal to sine theta?
Sine theta is opposite over
Opposite.
hypotenuse.
Okay, good. And what about the cos?
It is the base
Base
adjacent over hypotenuse.
over hypotenuse or base over hypotenuse. Base is also called adjacent and opposite is also called perpendicular. Then what about the tan?
Yeah. Opposite over adjacent.
Opposite over adjacent. Okay, now we have all the three sides. Mean if you want to apply the sine theta, then you also calculate the theta. If you want to put the cos, or you want to put the tan. For example, I want to put sine here. Sine theta is equals to opposite over hypotenuse. Then I want to calculate the theta, then the sign will be shift to the other side. Its mean sign will become to the inverse. So theta is equals to sine inverse opposite over hypotenuse. Now putting the value of
Okay.
opposite here, opposite is 15. So we put 15 here, and hypotenuse is 18. Putting here 18. It means sine inverse 15 over 18. Calculate the sine inverse 15 over 18. How much is?
Yeah, I'm checking it. I'm checking. 56.4.
56.4 degree. That is our direction of the displacement of OP. Got it?
Okay. So we say 56.4
Degree.
towards.
Yeah, 56.4 towards this, because the direction will be mentioned here, na? Because from O to P, we calculate the O to P, and we want to calculate this degree. If we want to calculate that one, it's also, this one is the opposite and it is adjacent.
Okay, so towards south, yeah?
Not toward south, because that it's coming here. This one is south, it is east, it's west, and this one is north. Then it will be between here, na? The
Okay.
southwest, southwest, from south to. Giafan, any doubt?
Um, yes, one doubt. So if the question asks total distance, then we will add all the distance. But if they say for displacement, then we will use the
Yeah,
Pythagoras theorem, yeah?
example, sometimes they provide us a two-sided triangle, and then the third one they want to calculate it. Okay, sometimes they provide us the rectangle, and we will be break the rectangle into the triangles, two triangles. They depend upon the questions. When we want to when they want any displacement, na, that time basically they want a straight line from the initial to the end, from the initial to the end. If
Okay,
you.
but we will not add all. We will only use the Pythagoras theorem if needed.
Yes, yes, yes. In the
And
distance,
if
add all the
uh,
distance, all the lengths.
so we add all the lengths. Okay.
Yeah. When they want to know about the distance, then we add all the lengths. But if they want to know about the displacement, that time we are only measure the distance from initial point to the final point, and also calculate the direction, because displacement without the direction, there is no displacement. There is a distance. If we make a direction as well as the magnitude, that time that length is called displacement. Sometimes they are not asking about the direction. They are only mentioned here, calculate or determine the displacement. But displacement is a vector quantity. So you should remember it. Every vector quantity have a direction. So you must calculate the direction as well as the magnitude.
Okay.
Done?
Yeah, and one last question. Do I have to memorize the meaning of displacement and the direction? All of these meanings?
Uh,
The definition.
Definition is not, yeah, there are some definitions coming in your paper, like what is power, what is displacement, what is a force. So these small definitions coming in your paper, there are a lot of according to your. So you remember your definition as well as. but not memorize it.
Okay.
Clear the concept. You make your definition by your own words.
Okay.
Got it?
Yeah. So, can you send me this PPT PowerPoint?
Yeah, why not? I signed it, but don't worry about it. Okay, you have my number now. So you give me a message, text from your own numbers. I share this documents also, and also the my worksheet, the past paper which we done here. Then I share all the things with you. Okay?
Private contact. Yeah.
Yeah, private contacts.
Okay.
Okay. Okay, today we are completing this topic, distance and displacement, and example of distance and displacement, how we calculate the distance and displacement. Inshallah, in the next class, we are discussing about the speed, velocity, and acceleration, and with graph, inshallah. And you want to know about anything else?
Yeah, I want to know the simple pendulum.